Okay, so 64-bit mode doesn't really have segmentation, but it does support FS and GS. FS is kept pointing to the current task record, task structure, and the first address in the task structure is a self-addressed pointer. That we'll get into that in a second. Anyway, so a task record has stuff like there's one window per task, and these are the window dimensions and position. The registers when the scheduler swaps it tells the GS segment points to the current CPU structure, and this is the task CPU. It has the callbacks for drawing, and it has anyway, this you want to get familiar with it. I add user data that's for you to play around with. It's not really a workable solution. If you want to add extra data, you have to create a frame in the symbol table. Anyway, that's the proper way to do it, unless you're me and you can modify the structure. So if we say class rep D, this is all the information the compiler has about classes and stuff is still available. So the class name comes first. So we want C task, and then you give you do your debugging at the command line. Anyway, so that this will dump a structure dynamically. So it knows all the compiler information about this class, and it shows all the members, and you can go deeper. So the FS segment register is kept pointing to. Let's look at. The first one is self-addressed. See, well, you can't really, you wouldn't know the difference. Anyway, so the FS segment register is kept pointing to the current task. The GS is kept pointing to the current CPU structure. If you want to see what a CPU structure looks like, it has a number, that's the number of the CPU, and it has the idle. You need that when you're scheduling. You monitor how much load it has. That's the complement of the CPU load. That's pretty much. It has a interrupt descriptor table, task register. It has a Seth task. Seth is the child of Adam, and there's one special task on each CPU that's the Seth task, and it needs an idle task too. Anyway, so where was I? So the FS and GS have to be changed with model specific register, and then it gets really tricky. Let's look at how we want to get the FSRIP. What it does is it this 32-bit displacements are RIP relative, which the addressing mode is inconvenient. So what you have to do is you have to XOR to get a 0, and then load an offset off of 0 instead of just an offset. And ideally, if this were 32-bit mode, you would do it like this. But in our case, you have to do it with this XOR 0. And there are times when you have to get the self-addressed. The FS is the first value is the self-addressed value. Anyway, so so the class rep D, the document D FS, this shows you can modify this live. You can also modify class rep D. You can put a size. So the window coordinates are somewhere in here, and we can modify. These are live widgets. To show that it's live, let's go back to whoops. Okay, so this document has a widget. When it was created with a Control L will create a widget. Create a widget. If you do text, and you can say nothing, and define string. If we say my define, we just created a text that's my define. Now if we say my define help, then if we come in here, it says help. These are string indirection, and it works. Lose those is for dynamic documents, not printing. I decided, unlike everybody else, I'm not doing a stream. There's not a standard in, not a standard out. These are dynamic structures. This is not a general purpose operating system. Anyway, so where was I? So the bottom 2 gig is called the code heap. So when it puts global variables, and it puts code in the code heap, it keeps track of which task owns it so that it frees it. That's because do you understand if I say ASM here, call, let's say DU8 testing, comma 0. Actually, I shouldn't have. So we have code trace on. That's why. Here are 2 bad labels. Push RSI, move RSI, comma here. Call address, put string. That's an import. Look at the example code to learn these things. I don't have to. I should do ES. Okay, so I just made some code. Let's unassemble. Unassemble works with for functions. You put an ampersand. If it's a assembly, if it's a C function, you put an ampersand in front. Otherwise, you put just the assembly symbol. And for assembly, you can only have the symbol defined once. For C symbols, you can redefine them, and it overshadows. So let's see, we want unassemble here too. So when we unassembled here too, we have code trace still on. Code trace off. Now unassemble here too. Okay, so here's the push. Look at this. It loaded a 32-bit value. That's because it's in the code heap. And then it did a call. This is a 32-bit. This is a 32-bit call because it's in the code heap. if I didn't have a code heap, I would have to work a lot harder. I would have to use more instructions, and then it does a pop. There's not a most operating systems have kernel in the upper memory. I don't have that. I just put all code mixed up in the lowest. So it just printed testing right there. So I put all code in the lowest 2 gig, but I can allocate big chunks. Actually, memory can get fragmented because I don't use. I always identity map. I give lectures on if you want to play with page tables, I set it up. If you want to play with ring 3, I set it up. If you want to play with PCI interrupts, I give lectures on that in screen memory and timing instructions and some tricks. So you probably want to look at those. It's identity mapped, so all tasks on all cores have access to all memory at all times. There's some device memory in a gap. The lowest 2 gig is code heap. Then there's some data. Then there's a gap for 32-bit devices. I don't really do any PCI devices. Then it can go up to I think 64 gig or something, or I forgot, 128 gig. What did I say? These are dynamic. You can change the limit. Anyway, I want to show one more thing. What was I going to show? Okay, so Control Alt Escape creates a new task. Alt V makes it vertically tile. Let's get rid of one. Shift Escape. Alt V. Okay, so now we have 2 tasks. Now let's say I64. Let's do I. There is no I symbol. So if I say I64I equals 1, 2, 3, I just made a variable I. Okay, now it's 1, 2, 3. If I come over here and say I, that doesn't exist. Now, what about J? That doesn't exist. Now, if I say Adam, this Adam sits in a server loop, and he will compile code for you. Adam J. Now, since everybody inherits Adam's symbols, if Adam defines a global variable J, suddenly J equals 567. Suddenly, everybody has J available because everybody inherits his symbols. So he has J now. You can do a map of all symbols, alphabetical order. I keep everything. When I had a Commodore 64, that book told what everything did, and that's what my goal is.